Okay, so ready to get our hands a little dirty today. We're going on a deep dive to explore rocks and soil.
Sounds fun.
I think everyone listening is curious to learn about how rocks and soil form and the incredible variety that they come in, and what they can tell us about the history of our planet. And to help us on this journey, we've got this really cool educational PDF all about rocks and soil.
Yeah, it's really amazing when you think about it. We walk all over rocks and soil every single day, but I don't know about you, but I rarely stop to think about, the stories that they hold,
Yeah.
like these secrets about Earth's past.
Yeah, they're like time capsules.
Yeah, exactly.
So let's start right at the beginning.
hmm
How do rocks become the foundation for everything else? I mean, what role does the breakdown of rocks actually play in this whole process of soil formation?
Well, that's really the first step. Rocks, they might seem like they just sit there unchanging, but they're constantly being broken down. And this process, it's called weathering. So, like, imagine a mountain range, and
Yeah.
it's slowly being sculpted by wind and rain over millions of years.
Wow.
That's physical weathering. It's like nature's chisel, just chipping away at the rock.
And that's happening all the time, everywhere.
Yeah.
I mean, the scale of that it's just mind-blowing.
Yeah.
So is that the only way that rocks break down?
No, not at all. There's also chemical weathering. This is where the rock's composition is actually changed.
Okay.
Um, so think about acid rain dissolving limestone,
All right.
creates these really incredible cave formations.
Yeah.
And then you also have biological weathering. This is where living things get in on the action.
Oh, interesting.
So like tree roots cracking pavement or lichens slowly breaking down rock surfaces, life finds a way. Right?
Life finds a way. That's right. So all these forces, they're breaking down these rocks into smaller and smaller pieces. So what happens to those pieces? Do they become soil?
Exactly. Those fragments are called sediment, and they're the building blocks of soil. And you've probably, like, if you think about it, you've noticed that the sand on a beach is different from the soil in your garden.
Right, yeah.
That's because sediment comes in different sizes.
Wow, okay.
So you have from tiny clay particles to larger sand grains and even bigger pieces like pebbles.
So if I were to perform sedimentation on my garden soil, I could actually see those different particle sizes separate out.
Absolutely.
That's amazing.
And the mix of those different sized particles is really what gives each soil its own unique character. It influences how well it drains water and how easily plant roots can grow.
So that brings us to drainage, which the PDF mentions 4 main soil types. Can you walk us through those?
Of course. So we have peaty soil. This type is rich in decomposed organic matter.
Okay.
So imagine like a sponge holding water but not becoming waterlogged. That's peaty soil. It's great for plants that love moisture.
Okay, and then there's sandy soil. I've always noticed how quickly water drains through sand. Like trying to build a sandcastle too close to the water line. Total recipe for disaster.
Exactly. Sandy soil is made up mostly of, well, sand.
I know.
And those large particles, they leave lots of air spaces so water flows through really quickly.
Huh.
Then we have the Goldilocks soil, loam.
Oh, loam. Perfect balance.
Yeah.
But what makes it so ideal for, so many different types of plants?
It all comes down to, that magical mix of sand, silt, and clay.
Okay.
Loam soil, it retains enough moisture for those plant roots, but it also drains well, preventing root rot.
Right.
And then also those smaller particles, they help hold on to nutrients that plants need to thrive.
So what about clay soil?
Yeah.
I remember when I was a kid playing with clay, it was always such a mess because it held on to water so tightly.
Yeah. That's because clay particles, they're incredibly small and they pack really tightly together.
Okay.
This makes the soil dense and it's slow to drain, but that same property, that's why we use clay for pottery, right?
Oh, yeah.
It holds its shape beautifully.
Makes sense. So we've gone now from solid rock to this complex mixture we call soil.
What's really interesting to me is that the PDF mentions how soil can actually hold clues about the past, just like rocks do, in the form of fossils.
Yeah. It's incredible, isn't it? When we think about fossils, we often picture dinosaur bones in a museum. But fossils can actually be found in all sorts of rocks and even in soil.
Really?
Remember how we talked about organic matter being a part of soil composition?
Yes.
Well, sometimes that organic matter gets preserved in a very special way.
So how does a plant or animal actually become a fossil?
Okay, so picture this. A leaf falls into a muddy riverbed and gets buried under layers of sediment. Over millions of years, those layers build up, the pressure increases, and the sediment turns into rock. Meanwhile, minerals slowly replace the organic material of the leaf, leaving behind a mineralized impression, a fossil.
Wow. So it's like nature's taken a snapshot of ancient life and preserving it for us to discover, millions of years later. Precisely. And paleontologists, they use these fossilized snapshots to piece together what Earth was like millions of years ago. It reveals ancient ecosystems, climates, even the evolution of life itself.
So every time we walk on soil or admire a rocky landscape,
Right.
we're interacting with this story that's been unfolding for eons. So what does this all mean for us, standing here on this ever-changing planet?
Well, if you think about the bigger picture, it reminds us that the Earth's surface is a dynamic, constantly evolving system.
Yeah.
Mountains rise, they erode, and they become the soil that nourishes new life. And fossils tell tales of creatures that came before us, living in worlds vastly different from our own.
It really puts things into perspective, doesn't it? This whole
Yeah.
journey from rock to sediment to soil, it's just this powerful reminder of the interconnectedness of everything on Earth and these incredible timescales that are involved in these processes.
Exactly. It kind of makes you wonder, though, what might the Earth's surface look like millions of years from now? What stories will be told by the rocks and soil of the future?
Something to ponder.
Yeah.
Well, on that note, thanks for joining me on this deep dive into the world of rocks and soil. We'll see you next time for another fascinating exploration.
See you later.